Bernoulli's theorem applications. One by one. Application number one is atomizer or sprayer. How an atomizer works. Any perfume bottle liquid is at low level. Question is, when you press a particular point, how the liquid flows out? That is what the question is. As per gravity, if you have an object, it can move to lower position. But in this case, why the liquid moves upward? The arrangement is, it is principle, it's not complete construction, it is only principle. If you press it at this point, the air present inside will move to the right, correct? If air at this point moves with high velocity at point A, speed VA is high. If at any point speed is high, previous part, P plus 1 by rho V square. Suppose we are not taking into account gravity. Suppose if V is high, pressure is low. So at point A, pressure is low. At this point, pressure is high. That is why perfume will move upwards. As it moves upward, there is a further more air coming, so it comes out in form of a fine spray. This is how a sprayer works. Time with you is 2 minutes to write. Left on aeroplane wing or any object which moves. Suppose the motion is towards left. If the object moves towards left, the air will move in this form. You can assume, say, practical, it is this object which moves. In a wind tunnel, how you perform the experiment? Aeroplane is at rest and the wind blows over it. So it is equivalent to, if this object moves towards left, it is equivalent to wind moving towards right. Yes. Streamlines, this point corresponds to what? Crowding of streamlines. Crowding of streamlines means what? This is marked as, let me check it, this is A or B. There are 2 points marked so that we are in resonance with the notes 1 and 2. Yes, this point is marked as 1, this marked as 2. What about V2? Velocity at 2 is high. Pressure P2 will be low. At this point, V1 is low, pressure is high. Means what? If this is the object, pressure below is high, P1 is more, P2 is less. So, net upward force will be equal to what? Pressure difference into area. You have number of numericals based on the same. That is why it is important to run the aeroplane at certain speed. If the speed reduces, this pressure difference will also reduce, and aeroplane may not be in a position to balance the weight. That is why there is an optimum, this is minimum speed at which the aeroplane must go. And if you make it like this, vertical, then this pressure difference reduces, and that is why the accident takes place. That is why for an aeroplane, there is an angle prescribed. That angle should not be more than certain value. Not more than certain value with the horizontal. You can't make it 90 degrees like this. 1 minute with you to write. It is left on the roof. Previous case, it is desired. But for a building, it is not. For a building, it is not desired. There is a building and a roof. It is inside, it is enclosed. This is inside the building. And this is outside. When wind blows over this, point 2, velocity is high. And pressure is low. What about inside? Inside is normal condition, speed is very low, and pressure is high. It will result in what? Yes, it will result in upward force. This is the roof supported by pillars or walls on the sides. Net pressure is upward. So upward force is equal to what? P1 minus P2 into A. If this upward force becomes more than weight, then during storm, it can take the whole roof and can shift it from one place to the other, sometimes kilometers away. It will happen in a case where the roof is supposed to be light. Where? Theaters. Why? Because it is difficult, not possible to provide pillars in between. You can give support only at the end. In the theater, you can give support only at the end, extremes, not in between. Otherwise, you will have to watch like this. You will have to shift from one side of the pillar to the other side. That is why generally the theaters are on top floor of the shopping mall. Lightest possible roof at the top. So supports at the end, and you can have a relatively lightweight roof. Once again, inside pressure is high, outside pressure is low. So force acting will be upward and can shift this roof from one place to the other. This is how blowing of roofs takes place. 2 minutes with you to write. If two boats are moving parallel to each other, boat number 1, boat A you can say, and another boat, boat B. If they are moving at a very high speed, then the water in between the two will also have a high speed. So at this point, again, point number 2 you can mark is high speed. Means what? Low pressure. And at these 2 points extremes, pressure is high. Pressure is high. What is the outcome? Yes. Two boats moving in same direction like this. In between the two, velocity is high, pressure is low. On the sides, that is this one and this one, pressure is high. As the two move, there is a chance the two may collide because the external pressure will try to move the two boats towards each other. So accident may take place. 1 minute with you to write. 1 minute to write. Low pressure near high speed train. Yes. On a railway platform, why there is a yellow line drawn and why you are advised not to move beyond that? Why? Suppose you are standing here and you are very close to the railway track. If a fast train passes nearby, speed is high, pressure will be low, and pressure at the back of the passenger, nearby standing person, will be more. So that person experiences more pressure outside and less pressure near the train. So the person gets sucked in. The arrangement is, if this is a train moving at high speed, nearby point A, pressure is low. Pressure is low. Points those are far away, B, pressure is high. And in case there is a person standing here, pressure at B is high, pressure at A is low. That is why there is a inward push to the person and the person may get sucked in near a fast moving train. That is why there is a line drawn and there is advisory not to move beyond that point. 1 minute with you to write this one.